Hello and welcome to this screencast on looping structures in Matlab, this time focusing on while loops. In this screencast, we're going to look at an overview of what a while loop is and compare it to a for loop, learn how to set up while loops in a written algorithm, look at the structure of how while loops are implemented in Matlab, and a couple of examples on top of that. So what is a while loop? Well, a while loop is another way to implement a loop, like a for loop, but from a different perspective. Now here's an example to illustrate that difference. Let's say I'm baking cookies. Baking involves a lot of repetition, and it's important to know the conditions under which you should stop. For example, when baking cookies, I have to add in 3 cups of flour. If I only have a 1-cup measuring cup, I have to repeat a process, filling up the cup and emptying it into the mixing bowl a set number of times, in this case 3 times. But other times I have to repeat a process not for a set number of times, but until a certain condition is met. For example, once I add all the cookie ingredients together in the bowl, I have to mix them until the batter is creamy. There's no set number of times to stir that will make this happen. I just have to monitor the conditions until it does happen. Now, in writing computer programs, you run into similar kinds of stopping requirements for loops. Suppose I want to do something a fixed number of times, like when I loop through the elements of a vector. This is what a for loop does, but other times I might want to repeat something until a condition is met, and I don't know how many iterations that will take at the outset. So here's a program example that will help us get into the main topic. Let's write a script that will find the smallest integer n such that the natural logarithm of n is greater than 10. Here's how a written algorithm for this might go. First, we're going to start by initializing n equal to 1, and then until the natural logarithm of n is bigger than 10, I'm going to replace n with n plus 1. Once I've reached that threshold, I display the n, and then I stop. That is, I want to keep adding 1 to n until the natural log of n is bigger than 10. This algorithm works fine in English, but to make it work in Matlab, we're going to change just one thing, and that's in line 2 here. Instead of saying until the log of n is bigger than 10, we're going to say while the log of n is less than or equal to 10, continue to carry out the adding 1 instruction. So instead of using until x, we're using while the opposite of x. This is going to allow us to use the construction in Matlab, and it's also included in many other computer languages, called a while loop. In Matlab, a while loop is structured as follows. We say while, and then we specify the condition under which we want the loop to continue. And while that condition is met, we do stuff. Instructions are carried out, and when the condition fails to be true anymore, the while loop stops. So it's syntactically similar to a for loop, except there's no counter, but rather a logical condition that, if met, tells the loop to continue to execute the instructions, and once the condition is violated, is no longer true, the while loop stops. Let's go over to Matlab and write up our program and see how it would look. So now we're over here in Matlab, and let's enter in our script, sticking close to the written algorithm. We first started by setting n equal to 1, and then we said while the log of n, and remember log is the natural logarithm in Matlab, sorry, wrong product. While that logarithm is less than 10, I'm going to do the following. I'm just going to increment n up by 1, n plus 1, and then we'll end, and then display the value of n. Now save this and run it, and it gives me back n equals 22,027. I believe you can check that, and it'll be right. The log of 22,027 is 10 exactly, according to Matlab here. So again, just to look in the code here and analyze it a little bit, we start with n equal to 1, and we have while, and here's my condition, while log of n is less than or equal to 10, I'm going to keep adding 1 onto it. So when we first encounter the loop in Matlab, n is equal to 1, and the log of 1 is 0, and that's certainly less than 10, and so Matlab carries out the instructions. Now n is set equal to 2, log of 2 is still less than 10, and so Matlab continues to carry out the instructions, and we just keep doing this until this condition up top here is violated. We do this as long as, or while, the log of n is less than or equal to 10, and any time, the first time that the log of n is not less than or equal to 10, that is, when the log of n is greater than 10, the loop breaks, and we bounce out here to this display command here, and we see what our n is. Notice that unlike a for loop, there's no counter involved here, and so I do have to initialize the value of n first and tell Matlab explicitly to increment the variable. We can get more examples of while loops by taking any for loop and converting it into a while loop if I wanted to do so. For example, take a look at this for loop here in the editor window. We start sum at 0, and then for I going from 1 to 10 and incrementing by 1, I'm adding I onto the sum and then displaying. All this script does is add up the numbers or the integers between 1 and 10, and if I run this program I see that it does add up to the right thing, 55. Now if I wanted to turn this for loop into a while loop, I have to think not about a counter but about a condition that will break the loop. Now actually, if I have a for loop to start with, I do have such an ending condition in mind. Namely, it's when I reaches the number 11 in this case. Once I reaches 11, the loop's going to stop. And so I can use that as the stopping condition for a while loop as follows. I'm going to just delete this stuff out. And I set sum equal to 0. And since there's no counter involved in a while loop, I have to initialize my I first at I equal 1. And now I'm going to say while, and the condition under which I want to continue the looping is when I is less than 11. I want to loop and continue to add on to my sum until I exceeds the number of 10. And so this is an equivalent condition of that. So while I is less than 11, I want to add I onto the sum. This was in the original for loop. And then since this is not a for loop but a while loop, I have to explicitly tell Matlab to increment the counter. So I'm going to add 1 onto I here, and then I will end. And then display the sum. Let me save this, and we'll run it, and we'll see that we do get the same result as we had before. So in the while version of this loop, I do have to initialize the counter starting at 1, because that's where it started in the for loop. When the while statement is first encountered, I is equal to 1. So in particular, it's less than 11, so we do enter the loop. I add I onto the sum, so now the first time through sum is equal to 1, then increment I to 2. Matlab looks at I and asks, well, is my I less than 11? The answer here is yes, so I go through the loop again. I add 2 to sum, which is now equal to 3. I add 1 to I, which is also now equal to 3. And again, Matlab looks at the value of I and decides whether or not it's less than 11. It is this time, and so we keep going. And we keep going until I increments up to 11, and then we stop. The for loop is better for this task than the while loop, even though we can do it both ways, though, because there are 2 fewer lines of code. But both loops can be done using either the for loop or the while loop. So let's recap what we see in this screencast. We've learned that there are 2 ways to do a looping structure in Matlab. If you want to iterate some instructions for a fixed number of times, then we use a for loop like we've done before. But if I want to iterate a bunch of instructions until a certain condition is reached, then I want to use a while loop. While loops use these conditions instead of counters, and the loop that we set up for a while loop will continue until my condition is false according to the syntax. Finally, we've seen that for loops can also be converted into while loops, and also vice versa. Well, we didn't see an example of that, but there's good reasons to choose one over the other. That's all for now. Thanks for watching.